Hey everyone. So in the today's video, we're gonna see about the Bayes theorem. How do we use it? What is the use of it, and how did we get this formula, the Bayes theorem? Okay, so let's get started. Okay, so we all are familiar with the conditional probability, that what it is, how we use it. Okay, so if you could see the conditional probability A, if that B has already happened, the events are here. Okay, these are the yeah. So these are the events. These are the events. The whole event is here. Okay. So what we want is that what is the probability of event A that has happened after the event B? Okay. So what is the probability of B event A happened after A? Okay. Did you get it? Okay. So what the our main objective here is that we have a sample space like this. Okay, we have the sample space and we have two events, event A and event B. Now what we want, that what is the probability of event A that B has already given that B has already occurred. Okay, and and we could get the conditional probability like this: the probability of A intersection B, the probability of this intersection here by the probability of B. Okay, as I have said earlier, or as we know that as the first event occurs, okay, as an event occurs, suppose that B has occurred, then the sample space reduces from this is the whole sample space, to this. Okay, if an event has occurred, then the sample space reduces. Okay, this is the main thing that you need to keep in your mind. Now we have two conditions here, that we could say that first one that what is the probability of A given that B has already occurred. So we could get this probability, which is probability of A give intersection B by the probability of B. Okay, this is the one condition that we have, not a condition, but this is one type that we can get the probability of. Okay, so the second one, we can also do the second one, that what is the probability of B given that A has already occurred. Okay, this one, this one. What is the probability of B that A has already occurred? Okay, now if we look very closely, then this place, this place is always same. Okay, the intersection between A and B is always same. Okay, so we could conclude that the probability of A intersection B and the probability of B intersection A is same. Okay, you see that? You see that? What is the probability of A intersection B or B intersection A? It is same. It is always be same, because this is the same event that be occurred, that will be occurring every time. It will be same. Okay, it will be always same. Okay, so we did some manipulation. We did some manipulation, and the manipulation is like that we the RHS of the site. Wait, yeah. So the RHS, this is our RHS. We kept it in the RHS, and what we did that we moved this place to here. Okay, it was a division, and after the equal sign, it became into multiplication. Okay, we all know the basic maths. So this happened like this: probability of A given that B has occurred into probability of B. Likewise, similarly, here, what we did here is we kept this in the uh, RHS right hand side, and then what we did actually is that the probability of B given that A has occurred into probability of A, and this was the probability of this. Okay, this event, this. Okay, so the both are same. These both are same. So these both are same. See, what is the intersection between A and B? What do you see? If you see here, then if you look at from this side or look at from this side, this always be same. Okay, if you look at from this side or you look it from this side, this will be always same, or you look it from this side also, this always be same, this place or the area of this place always be same. Okay, we're not about area, but if we talk in the terms of area, this the place of this area will always be same whether you look from this way or this way, this always same. So we did a manipulation, and what we concluded that the probability of A intersection B or B intersection A, it is always the same. Okay, it's always be same, it is always gonna be same. So what we did that we created the equation, and we concluded that this will be equal to this, because this is equal to this. So here what we have, that this is what we have here, that the probability of A intersection B equal to probability of A given B has already occurred into probability of B. Okay, this is nothing but our the first conditional probability that we can make. Okay, the first type of conditional probability we can make from these two events. Okay? And the second one, it should be same. It should be same. Why? Because the RHS is same. So its LHS must be same. Okay, simple maths. And it's like this. Now, what we want, that we have done the conditional probability of an event. Okay, of an event. Now, I want the probability. Okay, from this equation C, from this equation C, I want the probability of A, event A, given that B has already occurred. Okay. And if we see this equation, forget this. Okay. If this is equal, we have to focus on this. Okay. We have to focus on this. So after seeing this, if we have to find the probability of A, given that B has already occurred, then simply we won't do anything. We would just move. Wait, what happened actually? Yeah. Yeah. So what will we do? That we will simply move this to the air. Okay, it is in the multiplication, and what it what is going to be after the equal sign. Okay, it will nothing be, but it will be into the division P of B. Okay, if you could see that P of B, and this, and here this is nothing but the manipulation. After the manipulation we got the Bayes theorem. Okay, and after the manipulation we got the Bayes theorem. It is nothing but the manipulation of conditional probability of two events, or many events can happen, but mainly the two events that we can get from this place, which is this. Okay, which is this. Okay, so what is saying that the probability of A that B has already occurred will be the probability of B A has occurred, given that A has occurred, into probability of A by probability of B. Okay, and now we have some terminologies. We have some terminologies for the Bayes theorem itself. It has its own terminologies. We see then this this term, what we call it, is a posterior. Okay, and why do we call it posterior? Is because that it is gonna be the last result we gonna see. Okay, this is gonna be the last result we gonna see. That's why we call it posterior, because it's gonna be result, and we'll seeing this later. Okay, and this is the likelihood that it is a probability of event B, given that A has occurred. Okay, it is just a terminology. So it's nothing but just a terminologies that we need to know just for that. And this is prior. Okay, what this prior means? Okay, so if you see, then we would have some belief that A would have that much probability, this probability of that much probability. Okay, so now what we are doing, that we are updating our information. Okay, we are updating our information. So what happened actually, we all know that once an event has occurred, suppose that B has occurred. Okay, B has occurred, then the probability of the whole event will be different. Now, if we were wondering, like, what is the probability of A when B has not occurred, then the probability of A would be different. If we see that what is the probability of A if B have not occurred, then the probability of A would be different if B haven't occurred. Okay, This is the thing. This we need to understand that. What is a prior? Prior is like what is the probability of A if B have not occurred yet? Okay, this is nothing but the probability. Okay, I'm repeating. I know I'm repeating, but yeah, you need to understand that what is the probability of A if B have not occurred? This is the probability prior, and now we have to update. Now we have to update our information because we are wondering that the probability of A is not going to be same after the probability B has occurred. Okay, the probability of B will not be same if the probability of A will not be same if B has occurred, and that is what we are updating, and that is what we are updating. Okay, and what is the sample space we are taking? It's nothing but the probability of B. Is nothing but the probability of B because the B has already occurred. And what is the probability of A given that B has occurred? Okay, so what we were thinking. Okay, you getting it? I'm thinking. Okay, I'm thinking that you would be getting it. So it's nothing but that first, what we did, that we first assumed that A, the probability of A would be something. Okay, B has not occurred. The A would be something. Now, okay, it would be something. It would be something called X. Okay, suppose that something called be X. It would be X. Now, B has occurred. And what is the probability of A when B has already occurred? Okay, this is what the probability we have to find. So what we did actually, that we took the probability of B given that A has already occurred. Okay, and it is always be it is nothing but the likelihood. Okay, and this is prior the our previous assumption that what is the probability of A. Okay, this is the evidence. This is the evidence. That's that which is saying that we have the evidence that P has already occurred. Okay, this is we have the evidence, like the evidence for that, for the this formula or the theorem, which is saying that how would you find the probability if the previous event have not occurred? Okay, just think little bit different. That what we have said, that it is saying, this is saying that find the probability of A given that B has already occurred, and this is the evidence for the B has already occurred. Okay, this is the nothing but the evidence for this. Evidence for this. How would you get? How would you find the probability if B has not occurred? Think. How would you find the probability if B has not occurred? So this is not. This is for that, for the evidence that yeah, that we are B has already occurred. Now we can find the next event's probability, that what the probability of A gonna be if B had already occurred. Okay, so it's nothing but the evidence for showing that the B has already occurred. And what is the probability of the next event? Okay, and what is the probability of next event is simple of A. Okay, it's simple, nothing but of A. Now we got what is the prior probability. Prior probability is nothing but the probability of an event which has not occurred yet. Okay, we are taking our assumptions that A would be something, the probability of A would be something before occurring of B, and that is our assumption. And now what we did, that we updated our assumption or like probability. Okay, so it's nothing but this formula. We don't have to revise that. We just have to find. We just have to think about that. What is the probability? Okay, and if you think about, we don't have to revise it. Remember that this formula. This it would be, if we don't remember this formula or theorem, what it would be like, as I said, if an event occurs which is B, if an event has occurred, the sample space reduces the sample space to the event of to the sample space of the event itself. Okay, to the sample space of event itself. Okay, and what do we have to find? The probability of this event, the probability of this event, that what is the probability of event of this occurring, okay, occurring of this event. Okay, that we have to find. So in the sample space we would take the probability of the event which is nothing but the B. Okay, so what will we take? Wait, what will we take? The sample space of probability. It is, wait, let me do it in a, yeah. So it's nothing but probability of B. Okay, B is what is ours? B is the sample space. Okay, B is the sample space. Now we had an assumption that the probability of A, B has not occurred yet. Okay, in the earlier B has not occurred yet. What is the probability of A, of the event A, which is nothing but P probability of A. This is a probability. This is our assumption, not assumption, but the probability of A that was earlier, which is different now. Okay, into the probability of B. Okay, given that A has already occurred. Okay, it is that simple. I hope you would have cleared all the doubts, and if you have any doubts, you can ask me on the Discord or the comments, whatever, wherever. Or so yeah, thanks for watching till now. Bye.